Hello, everyone, and welcome back. Today, we're going to talk about simplifying the square roots. And these are the four square roots that we are going to be simplifying today, same as the ones in the thumbnail. Now, before we actually simplify them, though, I want to talk about how can we know whether or not a square root is in the simplest form. Often, a question will tell you to solve something and then simplify the square root or write the square root or the radical in general in the simplest form. And we can't really do that without understanding first what that entails, right? How do we know that a square root or radical in general is in simplest form? So the first thing we need to check is that no radicand should have a perfect square as a factor, right? Or if it's a cube root, same thing. It shouldn't have a perfect cube as a factor, right? If it does, that means we need to simplify it further. For example, if we have the square root of a squared times b, that's the same as the square root of a squared times the square root of b, and the square root of a squared is just a. And so we can rewrite this as a times square root of b. And then we've fully done it, assuming that b itself is not a perfect square, and also that b itself does not have any factors that are a perfect square. The next thing is that no radicand should contain a fraction. So, for example, we can simplify the square root of a over b to square root of a over square root of b, and now no radicand contains a fraction. Kind of going along with that one, the radical sign should not be in the denominator. And so when we do simplify to here with the second one, we still end up with this b in the denominator. So then we would do the third one in order to fully simplify this. What we do is we multiply both numerator and denominator by square root of b in order to then have in our numerator the square root of a times square root of b, which is just square root of a times b. And then in the bottom, we get square root of b times square root of b, which gets rid of the square roots, right? Both the square roots cancel, and we get b itself. Right now, if it was cube roots, we would need three of them, right? We'd need cube root of b times cube root of b times cube root of b, right? And so on. But in this example, we're just going to mostly be focusing on square roots. Okay, so let's get into the examples because that's probably why everyone's actually here. This first one is 5 over root 11. So let's see. First thing is no radicand should have a perfect square as a factor. Well, 11 is prime, and so 11 does not have a perfect square as a factor, other than 1. I think, I don't actually think it said that, but yeah, we can assume that 1 is okay to have. Just anything, any factors that are square roots other than 1 would not be okay to have. The second thing is that we should not have any fractions in our radicand, which that's fine. We do not, so that works for us. But we do have a square root in the denominator. So what I'm going to do is multiply numerator and denominator by root 11. And then on top, we have 5 root 11 over just regular 11. Because keep in mind, root 11 times root 11 gives us 11. And now all three of the conditions are met. And so this is the most simplified square root. Even though, maybe it looks more complex than the original, this is the simplified version because it meets all those requirements we talked about earlier. Okay, let's try this second one here. This one is root 18 over root 2. So first thing I notice right away is that root 2 is in the denominator, and we just can't have that. We can't have root 2 in the denominator. So I'm going to multiply both of these by root 2 over root 2, and I'm going to get root 18 times 2, which is 36, root 36 over 2. The next thing I notice is that root 36 is not only does it have a factor that's a perfect square, it itself is a perfect square. So I'm going to simplify that to 6. So then we have 6 over 2, and 6 divided by 2 is 3. So therefore the answer to this is 3. Okay, what about square root of 72? Well, there's certainly no fractions here, and there's also certainly no roots in our denominator here because we don't have a denominator. So the only possible thing that could potentially be wrong with this is it might have a factor that is indeed a perfect square other than 1. And it does, right? Recall that 36 times 2 is 72. So I'm going to separate this and say that this is the same as the square root of 36 times 2. And keep in mind that this is equal to the square root of 36 times the square root of 2. And square root of 36 is just 6. So this is just 6 root 2, like that. Awesome. Okay, so next one here is root 300 over root 27. So there's a couple things here that are wrong with this. First of all, we have a radical in the denominator, which of course we cannot have. And then we also have the fact that both 27 and 300 actually have, they have factors, or they have a factor at least, that is a perfect square. Now with this one, we could multiply both by root 27 first. I'm not going to do that because if I do that, I'm going to have a very large number in the square root at the top, and that could make it harder for me to find factors. So it's not that it's incorrect, it'll just make it harder to simplify. So I'm going to do the other step first, where we try to simplify numerator and denominator separately, and then after we take care of the fact that the denominator does have a radical and we can't have that. So let's look at root 300 first. What is a perfect square that is a factor of 300? Well, that would be 100, right? Recall that 300 is the same as 100 times 3. So that's our new numerator. And then what about 27? Well, 9 times 3 is 27. So we have root 9 times 3. And then we have 100, right? Root 100 times root 3 over root 9 times root 3. Now, in this specific example, I've noticed, we have root 3 in the numerator and denominator. Those can just cancel. Now, let's say that they didn't cancel because, that we won't always have roots that cancel. If they didn't, then we would still have to take care of the fact that there is a root 3 in our denominator by multiplying top and bottom by root 3. But because they cancel here, we can actually not worry about that anymore. Then we can simplify root 100 and say that's just going to be 10. And then root 9 is just 3. So the answer here is 10 over 3. All right, well, good work, everyone. Feel free to leave any questions you might have about any of that in the comments below, and we will see you for the next one.